All right, everyone, let's go ahead and get started on this assignment. Right, so number one, we're going to determine if the following graphs are a function. We're going to go ahead and use something that we call the vertical line test. All right, we talked a little bit about that today in class. So vertical line test is exactly what the name suggests. You make a vertical line, make sure it's not crooked or anything, make sure it's straight up and down, and you're going to take it across each graph and find out if it crosses it once. If it crosses it once, it's a function. If it crosses it more than once, it's not. So for example, letter A, it crosses it once, twice. So this one is not a function. Or I'll just write not function. Okay, that's all you gotta do, especially if you have a graph. Right, so letter B, if you take it across, you see how each time I move it across, the red line only crosses the graph at one point. Let's just say right here. Okay, if I move it somewhere else, let's say I move it right here, the line crosses the graph right there. So this right here is a function because it passes the vertical line test. So we'll just say this one is a function. Okay. Letter C, if you take it across, right, as you move across this graph, right, it'll touch it just one time. So for example, right here, it touches it one time. If I move it over here, touches it one more time, right? Only once. I move it all the way right here, I'll touch it once right there. So because it only touches it once, this right here is a function. So letter C is a function. Letter D, if I, for example, if I go right there on letter D, yes, it only touches it once. Okay. But as I move across this circle, it touches it once right there. And then now it touches it twice because as I move across, it's ending up hitting it more than once. So if it hits it more than once, or if it touches the graph more than once, it is not a function. So this right here is not a function. Okay. This one right here, letter E, you run it across this graph, just move it, the vertical line from left to right, or right to left, doesn't matter. But you can see as you move it left to right, it only touches it once. So this is a function. So I'll draw right there. So this is a function. Okay, last one for that set. F. Okay, and again, just like the circle, if I just put my vertical line right there, yes, it will only touch it once. Okay, but you gotta run it through the graph, not just leave it at one place. So when I move it across here, like let's say right there, you can see that this red line, the vertical line, is now touching that graph at two locations, and this right here would be not a function. All right, so that's numero uno. If you need to review it again, go back to the beginning and watch that first part again. Okay. Number 29, evaluate the following absolute value expressions. So it's been a while since you guys have done absolute value, but absolute value, basically the idea is that absolute value is the distance away from zero, right? So for example, negative 100, the absolute value of that, and here's a little hint right here, right? So the distance away from zero of negative 100 is 100. So the absolute value of negative 100 is 100, and then you got to go minus 98. If you need help, use a calculator, but that's going to end up being 2. Okay. All right. Next one. Okay, and here's a hint. Subtract first, and then take the absolute value, okay? And then multiply by 5 lastly. So you got to make sure you subtract inside the absolute value. Okay, so 2 minus 8, that's going to give you, and you still have the absolute value because we haven't done any absolute value. So 2 minus 8, if you're having trouble, use a calculator, but 2 minus 8 gives you negative 6. Okay, so you found that. Make sure we multiply by 5. Okay, now we got to do the absolute value. So the absolute value of 6, or excuse me, absolute value of negative 6 is going to be 6. So we got 6 right there. No more absolute value. And then we got to multiply by 5. So 5 times 6 30. Okay. Letter C, absolute value of negative 13, or how far is the number negative 13 away from 0, right? So here's the idea. Okay, here's your number line. Here's 0. There's negative 10. Here's negative 13, right? So here's negative 13. So when we say absolute value, we want to know how far is negative 13 away from 0, right? And we say that that's a distance of 13. Okay. So yes, absolute value makes everything positive, but what it really is absolute value is the distance away from 0. Okay. So with that, so absolute value of negative 13 is just 13. Plus an absolute value of 0, okay, is 0. Because 0 is 0 distance away from 0. And 13 plus 0 is 13. All right. Letter D. All right, no hints on this one, but if you're going to do it, you need to do the stuff inside the absolute value first. So negative 10 plus 13, and that's going to be negative 7 inside the absolute value. Okay. Now you write the rest of it down. 14 minus that. Okay. Now you're going to go ahead and work the absolute value. So how far is negative 7 away from 0? Right? That's what absolute value of negative 7 means. So absolute value of negative 7 is just 7. And then you just write the rest down. 14 minus 7, which comes out to be 7. All right. So that's number 29. If I'm going a little fast, you can pause it, or you can go back to an earlier time. All right, last one, number 20. Okay, create a tile pattern. Okay, so you got to make your own tile pattern, and just because I made a certain tile pattern doesn't mean that that's the one that's the only right answer. There are many right answers out there. Okay, you can be as creative or as boring as you like. All right, so create a tile pattern that matches the table below, and be creative and make your pattern interesting. All right, so it's up to you. But if you want to follow me, so figure 0, which is right here, figure 0 is going to be 2 tiles. So I'm going to go ahead and just put 2 little blocks next to each other. Okay. Figure 1 is going to be 5. So figure 1 is going to give you 5 tiles. So basically, I have to have 2 to start out, and that's what figure 0 was. But to get 5, I need to add 3 more. So you can do it any way you want. I'm going to be kind of boring, and I'm just going to put one on top in between the 2, and then right there. So that's 5. Okay. Figure 2 is 8. So I'm going to do the same thing as figure 1. Oh, actually, I can cheat because I have this awesome computer. Okay, so that's 5. And then what I'm doing is I'm just adding 3 more. So 6, 7, 8. Okay. And figure 3 is the same as the other one before, but I'm adding 8. 3. Right, so I have 8, and then I'm adding 3 more, okay, which makes 11. So 8, 9, 10, 11. So my figure looks kind of boring, but it gets the job done. Right? So I created a tile pattern. What's the growth rate? And you probably saw me doing this, but from 2 to 5, the growth rate is plus 3. From 5 to 8, the growth rate is plus 3. 8 to 11, the growth rate is plus 3. So all I'm doing is starting with 2, and then what I did was I added 3. That's how I got 5. And then I went to 5, and I added 3 more. That's how I got 8. And I went to 8, and I added 3 more. That's how I got 11. Okay? So a growth pattern is add 3. Right? Write an equation. Okay? So some of you guys may remember what I talked about the other day, but your equation, because it's adding the same amount, it's a linear growth, it's adding the same amount. So that means that we can actually start with figure 0, and figure 0 actually has 2 tiles. So that's where we start. So the equation should be y equals, or if you want to be fancy, you can use f of x because we just learned function notation. So we can use y equals, and then we start with 2, and then we're adding 3 every single time. So we don't just put plus 3, it's going to be 3x, right? Then the 3x stands for 3 for every single time we add. So if we add 3 one time, then that's going to be a 1 right here. That's what x is, right? If we add 3 and then we add another 3, then that means that we're adding 2 of them, which is going to be 6. See? So that's why you need the x. You don't just put plus 3. Okay, you have to do 2, which is figure 0, the beginning, plus 3x. Okay, so this is fine. Or if you want, so this is okay right here. That's a very good answer. But if you want, you can write it as a function notation. You can write it as a function notation, and you can write it as f of x equals, and then I'm going to go ahead and put it in the right order, or not right order, in a more preferable order. So I'm going to put the 3x in the front. Okay, you might have learned that back in the middle school. So 3x, and then, so that's a positive 3x. If you look here, it's positive 3x, which is the same as my positive 3x. Okay, and then you look here, it's a positive 2. So I'm going to go ahead and put plus 2. Right, and this right here will also be acceptable. Okay, so you can do y equals, or you can do f of x, and then you can write it as 3x plus 2, or you can write it as 2 plus 3x. Either way is fine. All right. Okay.